Well, good afternoon, everyone. Thank you so much for joining us for the second of our scientific symposia that we're holding today. This morning, we talked about the Stuart Scott Memorial Cancer Research Fund and about what we're doing with research to overcome some of the inequities and disparities in cancer, and particularly what is affecting people of color. We couldn't find this to be a more appropriate time to have that conversation. And given the fact that we've been doing this research for so long, we have a lot of findings already that we have been able to share. So we'll make some highlights of that available to you online. This afternoon, we're happy to be able to talk about the Robin Roberts Cancer Thrivership Fund. And Robin is on our board of directors. And when we talk to her about the things that are nearest and dearest to her and have been so important in her own cancer journey, it has been what it is to thrive after some of the very difficult things that cancer brings to the table. We're also going to hear from the first recipient of the Robin Roberts Cancer Thrivership Award, Scott Hamilton. So stay tuned for that as well. I'd like to start out, though, first of all, asking your forgiveness. We're new at this, and so please bear with us if we have some technical glitches, but also to thank several of our important funders for what they have done to help us make this research possible. So the V Foundation thanks Bristol Myers Squibb, and we'll be hearing in a moment from Mark Peters at BMS. ESPN, our forever best friend and partner in all that we've done. Robin Roberts and the guests at her annual evening with Robin Roberts and the Scott Hamilton Cares Foundation, all of whom have been a part of raising these funds and making these funds available to researchers who are looking at some of the most pressing issues of cancer thrivership. Now, if we put up the next slide, I'll tell you a little bit about the Robin Roberts Cancer Thrivership Fund. We've just recently begun this fund. I told you about the history and talking to Robin about it. So we began making awards in 2018. And so far, with the help of all of these wonderful partners that I've talked to you about, we have been able to award $5.4 million in grants. We're going to talk to you today a little bit about those grants and talk to some of the grantees. But some of the areas that we look at, because we look into biological bases of and prevention of long-term cancer treatment side effects and other sequelae of cancer and its treatment, are things like premature deaths and second neoplasms or cancers, organ dysfunctions, reduced growth and development, especially, of course, in children, decreased fertility in young adults, impaired cognitive function. So a lot of things that are important to help the millions and millions of thrivers in this country have a better journey after cancer. We have funded across the country. You can see the various states where we have funded grants. And we will be talking a bit about what those grants look like, what they're telling us, what we can learn, and what is left to do. Just one more piece of housekeeping before we go on to the rest of the symposium, and that's if you have any issues, technical issues, with the Zoom webinar, here's the number you can call, 919-443-3588. You'll get a live human who will talk you through the issues that you might be having. All right, let's get on with the program. If you have questions for any of our presenters, you'll see that at the bottom and or the top of your screen, depending on what device you're using, there is a Q&A button. You just can tap that and then type in a question that you have. You can either send that directly or direct it at an individual presenter or a general question that you might have. And we will do those Q&As at the end of the entire session, so please stay tuned. So I would like to start out by asking Mark Peters from Bristol Myers Squibb if he would like to say just a few words before we kick off the presentations. Mark?
Thanks, Susan. It's great to be with all of you today, and really appreciate the opportunity to say a couple words. And really, on behalf of Bristol Myers Squibb and all our employees, I wanted to thank you for the privilege to really support the Robin Roberts Cancer Thrivership Fund. As many of you know, today more than ever, people are living with cancer longer, but this then presents some unique challenges. And now that we have this great fund that not only Bristol Myers Squibb, but many other groups, including ESPN and Scott Cares Foundation Scott Hamilton Cares Foundation has supported. It's so important to see how this research is coming along, and really, really excited about this afternoon and seeing that research. So again, on behalf of Bristol Myers Squibb, really thank the V Foundation for the privilege and the honor to support this work on behalf of the Robin Roberts Cancer Thrivership Fund. Thank you, Susan.
Thank you so much, Mark. And it's also my pleasure to announce that Bristol Myers Squibb, just today, we are able to announce, has given an additional $1 million towards the Stuart Scott, which is so amazing. Thank you, towards the Stuart Scott Memorial Fund. And they have already put millions and millions of dollars into these cancer thrivership grants. So Mark, thank you to you and your team for everything that you have done to continue this quest with us towards victory over cancer. Thank you so much. Our wonderful friend, Scott Hamilton. Scott has been a friend of the V Foundation for a long time, and he is so near and dear to our hearts. I need to start my video. Okay, I can do that. All right, there we go. Scott is so near and dear to our hearts. We just adore the work that we are able to do with him and with the Scott Hamilton Cares Foundation. And many of you have read Scott's book, have watched him compete in the Olympics, have seen him as a speaker. But for you to know the man and his kindness and compassion and the love that he shares in the world is a great, to me, it's one of the greatest gifts in life. And Scott, you are a gift to us. So over to you to talk to us a little bit about survivorship and thriving. There he is. There.
Thank you, Susan. There is no better leader. There is no better leader than you. You are, you lead with your incredible mind and your beautiful heart. And there is no better representative for all of us who are trying to make a difference in the cancer community than you. And I am so grateful for this opportunity to be a part of this symposium. I gotta say, I love the distinction between thrivership and survivorship. All right, it's completely different. As you just mentioned on that slide, I mean, there's so much that can happen in a cancer journey, adventure, that the long-term effects, the fact that, you know, by you know, just everything that we endure through cancer, that you know, that there's more. It just doesn't seem fair. I lost a loved one, my mother, to cancer in the late 70s. She was the center of my universe, and watching her, her spirit, her just her vitality and everything diminish through massive amounts of chemotherapy, surgeries, and everything else they could do to try to help her win her battle. It was just devastating to see. Just, you know, that was the best they could do then, and to see how far we've come in understanding cancer and the improvements in cancer treatments. It's like, oh, I only wish that some of this existed back then, and maybe I would have had her a lot longer. We still have a long way to go, and I'm encouraged by days like today when we can celebrate the achievements of research scientists and their quest not only to save lives, but also the quality of those lives. I was diagnosed with cancer in 1997. I remember it like it was yesterday because it's kind of a big day when you're diagnosed with cancer. And it was really funny how it all went down in a really odd way. You know, they said you have stage 3 testicular germ cell cancer, blah, blah, and it was like, no. And they go, no, 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 this is a good one. I mean, a good one. They said, if you had to pick a cancer, this is like a really good. I go, who would pick a cancer, right? So I decided in that moment that, you know, I really desperately wanted my life back, and I was going to be the best patient they've ever had. The way that the chemo regimen for testicular cancer, you know, for me, it was 5 days in a row of 8-hour infusions, and it was 3 different chemotherapy drugs. And every Friday there'd be a shot of bleomycin, which was my least favorite day of the week by far. Bleo Fridays were brutal. But it was, you know, it taught me so much about what people face day to day when they're going through a cancer journey. I wanted to quit after round 3 because my whole physicality in my life had changed. You know, I asked them at the beginning, how sick am I going to be? And they said, moderate to severe. And I go, what does that mean? They said, moderate to severe. And I said, okay, well, we got a long way to go in helping people endure their cancers. And I also asked if I would be different after I was finished. And I was told that, you know, I was going to get a drug that might inhibit my lung function, but they'll keep an eye on everything to make sure that they minimize the damage. And it's like, I'm an athlete. I can't have diminished lung capacity. It's like, that's not fair. But they kept an eye on it, and I was able to kind of get back to a high level of function because I dove right back into all my physicality after my chemotherapy and surgeries and everything else. When I was given the you're cancer free, you know, that the chemo worked and that everything should be good in that regard from this day forward, you know, I kind of thought, that's great. And I go, I mean, but what are the long-term effects? And they go, you should be really kind of good for the next 20 years. After that, you know, there could be some things. Fertility is always going to be an issue. Cardiovascular issues need to be considered immediately. But they said, you know, in 20 years, increased chances of heart attack and stroke. And I'm 23 years survivor, thriver. And I can tell you that I am working really hard to be healthy, hydrated, and I make the best choices that I can make in the way that I handle my physicality. You know, it doesn't seem fair. I do believe that the cancer community is better than that. And I think they're proving to be better than that. And today we're hearing about the future of cancer treatment options and exactly what Robin Roberts has done by participating in this way, not only through her very public battle with cancer that gave great hope to millions and millions of people, but she also fought hard to get her life back completely and fully. She celebrates thrivership. It's more than surviving cancer. It's living your life authentically. It's not being diminished in any way by your cancer, but it's really attacking life in every way you possibly can, like I try to do, to be even better than you were before and sort of richer by the experience. I had the honor of being the absolute first ever thriver at Robin's big New York fundraiser, and it was unbelievable. It was a great event, and it was such a thrill to be her first Thrivership Award winner. And they raised a lot of money for the V Foundation while we were celebrating life. I 100% believe that the future is getting brighter for people facing cancer. I do. The research being funded by the V Foundation and Robin Roberts is changing the way we look at cancer and inspires hope that we won't have to trade our quality of life to survive this insidious disease. And that's why my foundation, the Scott Hamilton Cares Foundation, partners with the V Foundation to advance immunotherapy research. We believe that it's possible to treat the cancer without harming the patient. You know, for the first 15 years, it was about looking after the patient experience with cares emotionally and intellectually while still doing, you know, research. But now in our 6 years as an independent foundation, we are 100% into just research and partnering with the V Foundation to come up with better ways of teaching our bodies, our own body's immune systems, how to recognize and destroy the cancer. This is an exciting day we live in, and it's just going to keep getting more exciting, because the more we learn, the more we know, and the more questions are answered, the more questions we know to ask. And that's an exciting time. And it is my pleasure now to kind of now step aside and allow our researchers to fill you in on the miraculous work they are doing. And man, it just fills my heart to not only recognize and honor my mother in this way, but also to stand beside every single person that survived this disease, in knowing that we're going to get better at this, and we are getting better at this. And we couldn't be under a better leadership than Susan Braun. Susan, take it away.
Oh, Scott, thank you. As always, you just inspire me. You make me want to stand up and down and jump and go learn to ice skate. Booyah.
Well, it's not too late. I can help you with that.
Oh, yeah. Okay. Thank you so much. I can just imagine your mom is smiling down on you and all of the things that you have done. And I could also just imagine you standing side by side. You probably are in spirit, side by side with every single person who's going through this disease, saying, you can make it. Yeah, thank you for that so much. So the first presenter today is Dr. Smita Bhatia. I hope I got that right, Smita. Sorry if I didn't. Who is at the University of Alabama, Birmingham, the cancer center there. She is one of the real early people who has looked at thrivership issues. She's done a great deal of research. She runs the Institute for Cancer Outcomes and Survivorship there at UAB. And she has been funded continually by the NIH since the year 2000. She is passionate about this research. She is a mentor to junior investigators. So please join me in listening to Dr. Bhatia.
My absolute gratitude to V Foundation for funding this research. And what I want to do today is to spend the next 8 to 9 minutes in describing some of our early findings in understanding what are the molecular underpinnings of anthracycline-related heart failure in children who have survived and thrived after cancer. So in terms of cardiotoxicity in cancer survivors, cardiomyopathy or weakness of the heart muscles is the most common, and it irreversibly leads to heart failure. The most common risk factor is anthracycline chemotherapy, and other factors which modify this association or accelerate this association are radiation to the chest, a very young age at exposure, and then female sex. This particular graph shows the relationship between anthracycline dose on the x-axis and the risk of developing heart failure on the y-axis. And what it shows is that as the dose increases, and especially as it increases above 200 to 250 milligrams per meter squared, the risk of developing heart failure increases exponentially. An important thing also to note is that once heart failure sets in our childhood cancer survivors, the 5-year survival is quite low, so the prognosis is low, is poor. Another important thing to remember is that there is significant inter-individual variability in the risk of anthracycline-related cardiomyopathy, such that if you were to look at these green dots, each of them represents a case, and they are aligned with the dose of anthracyclines. If you were to cut the dose of anthracyclines at 250 milligrams per meter squared, you would find that a large number of these patients developed heart failure at a much lower dose of anthracyclines. On the other hand, if you were to take childhood cancer survivors who also received anthracyclines and were to see, and they did not develop heart failure, you find that a lot of them received a fairly large dose of anthracyclines and escaped that heart failure. And this brings up the question about the role for genetic susceptibility. Now, within the Children's Oncology Group, we've developed a study and carried it out now for over 15 years, where we identify individuals or childhood cancer survivors who've developed the cardiomyopathy or heart failure, and we match them to controls or childhood cancer survivors who've not developed heart failure. We ask them to provide us with DNA, either in the form of blood or saliva, and ask them to complete a short questionnaire describing other conditions, health conditions that they might have. We also ask the institutions to provide us with all the details of the treatments that these children might have received. We asked the sites to also provide us with echocardiogram reports in order to describe the heart failure that these patients have. And so far, we have close to about 200 cases of heart failure and 400 controls. And this is from 141 participating sites. Now, these patients, the median age, the age at cancer diagnosis, roughly 7.5 years. Those who developed heart failure had a much higher dose of anthracyclines as compared to those who didn't. And when you were to look at their echocardiogram report, you find that this indeed did have a suppression of their heart function. This is just a schematic of what we think happens when anthracyclines are given. Higher doses of anthracyclines first have to be transported across the cell, and then they undergo a series of metabolisms and result in the formation of products that can increase what are called reactive oxygen species, toxic substances that cause mitochondria to not function well in the cells. This leads to the heart muscle cell death or apoptosis, leads to the remodeling, which is not very well structured and doesn't work well, and then eventually leads to heart failure. Also, we have to know that one of these products out here of the anthracycline metabolism is directly cardiotoxic to the heart muscle cell. Now, what we've also done with respect to research, we and others have shown is that there's a bunch of genes that are controlling the function of, say, the drug transport, preventing or enhancing the anthracyclines from crossing that barrier, the cell membrane, responsible for metabolism here and here, directly serving as antioxidants and reducing this toxic reactive oxygen species, and then working on the iron homeostasis or iron metabolism, and then preventing heart failure, and also finally working on the heart muscle contractility and preventing heart failure. What we've also done is looked at the function of these genes, and time precludes me from showing the details, but really shown that if you have a high amount of enzyme, which produces a large amount of this toxic metabolite, that it places the patient at high risk of heart failure. If you have low levels of this antioxidant activity, hyaluronic acid molecule, it results in high levels of this reactive oxygen species and causes heart failure. And then if there is this particular polymorphism in the gene, it results in decreased myocardial contractility. Now, if we were to take this particular schematic and work our way through, let me just explain this, how this would work. So in our cells, we have our brain, the DNA. It undergoes replication on a regular basis, but it also results in the formation of RNA, and then eventually in the formation of proteins. And the proteins are our building blocks and also the entities that ensure that all of our bodies function the way we want it to function. Now, we have, and others have identified, more than 100 genomic variants associated with heart failure. But we really do not understand fully how these work. it could be that some of these genomic variants don't themselves produce the protein or result in the production of protein, but work indirectly to enhance some RNA functions and then result in formation of other proteins, which is not directly obvious to us. And so the important question to be asked is gene expression controlling who gets heart failure and who doesn't? And we know that gene expression is strongly heritable, and we know that there's a technique which is cutting edge right now, RNA-seq, which allows messenger RNA levels to be quantified. And what we are doing as a result of the V Foundation funding is to measure the gene expression levels in cases and controls and see whether they are differentially expressed, and then help us to use these differentially expressed genes to go back to the DNA and learn more about the mechanism of how heart failure develops. So our hypothesis is that perturbations in these gene expression will lead to identification of novel and functionally relevant genetic abnormalities in individuals or childhood cancer survivors who develop anthracycline-related cardiomyopathy. And this will help us understand the mechanisms of cardiotoxicity. And so first of all, we want to identify these transcriptomic signals or our gene expression levels, but then we want to take this information back to human-induced pluripotent stem cell-derived cardiomyocytes, as well as the human myocardium, as well as the human liver tissue, and to truly understand exactly what's going on with these genetic variants. The patients that we've studied so far are about 8 to 9 years old at the time of diagnosis of their cancer. Those who developed heart failure received higher doses of anthracycline and were more likely to have received just radiation. They had acute lymphoblastic leukemia, bone sarcoma, or Hodgkin lymphoma. They were more likely to have diabetes, hypertension, or lipid problems, and they developed their heart failure about 5 years out from diagnosis. And this slide shows a network of those RNA genes that we have thus far identified. And so just to orient you, it means the bright red genes are the ones that are upregulated, meaning the gene expression is increased. Lighter pink, it means it's less increased, and green means that they are downregulated, meaning that they're not expressed as much. So let's focus on this particular gene called haptoglobin. And here is a figure of our haptoglobin gene in cases, the red bars, and green bars being the controls. And what we find is that amongst our cases, the read count of these expressions is increased as compared to the controls. And how does this particular haptoglobin work? It's an acute phase protein, which means it is very important for eliminating free hemoglobin, which causes oxidative damage. Individuals who have a genetic variant of this particular haptoglobin are at higher risk for developing cardiovascular disease, such as myocardial infarction, stroke, and heart failure in the general population, not in the cancer survivors so far. And haptoglobin is a risk factor for developing hypertension. So this is a particular new entity that we have identified so far. Another one is a gene called FCGR1B. And here again, we show you an overrepresentation or overexpression of this particular gene in cases and lower expression in controls. And this particular gene encodes a protein that plays an important role in immune response. It's associated with inflammation, such that resulting in atherosclerosis, acute myocardial infarction, and hypertension. In fact, in breast cancer patients, this particular gene serves as a pre-symptomatic biomarker in those who haven't yet fully developed the signs and symptoms of heart failure. So this is where these particular new genes that we've identified would fit in this schematic. And what I want to tell you is the next steps, wrapping up, showing that there are several other leads that we are going after now. And then moving on with our next step will be to look at the functional relevance of these genes that we identify. Why are we doing these studies? We really want to understand the underlying mechanisms for cardiotoxicity and develop effective treatments. We want to identify patients at highest as well as at lowest risk for developing cardiomyopathy, and this would help us provide personalized treatment to our patients. And eventually, our goal is to reduce the morbidity and mortality associated with anthracycline-related heart failure, and thus allow our cancer survivors to thrive. I want to end by thanking the V Foundation, but also our patients and their families. Without them, this work would not have been possible. Thank you very much.
Thank you so much. Let me just put this back on. Thank you so much, Dr. Bhatia. We appreciate it, and that's very helpful. And all of your research over time has just been so meaningful and leads the way for so many of us in understanding better how we can help people who've been through the cancer journey come out the other side thriving, the way Scott so aptly described it for us. So thank you very much. Our next presenter is Dr. Saurav Armenian, who is at the City of Hope National Medical Center. He runs the Division of Outcomes in the Department of Population Science at City of Hope at the Cancer Center there. His research focuses on understanding the long-term outcomes in cancer survivors, and he's going to talk to us a little bit about clonal hematopoiesis and its impacts on outcomes after autologous hematopoietic cell transplantation. So, Dr. Armenian, over to you.
All right, so I do want to say it's a special thrill to present to you all. The V Foundation has a remarkable track record of funding really interesting and innovative studies, and I feel truly privileged to have had our research funded through the V Foundation. It's also a special thrill to follow Smita Bhatia, who has really been a pioneer and a personal mentor, and who's really led the way for a lot of the work that we've been doing, as well as others who will be presenting today. So without further ado, I want to talk a bit about this concept that I think others will talk about later on today as well, is this emerging concept of clonal hematopoiesis. It's a long, sort of complex set of words, but ultimately what we really are talking about is a research that's going to help understand why some people go through treatment without any issues, and then others face unique obstacles, not just during the treatment, but many years afterwards. So what I'm talking about today it's mostly about patients who have undergone a bone marrow transplantation. We call it hematopoietic cell transplantation. They're interchangeable, HCT. So bone marrow transplantation really emerged in the 70s and 80s as a revolutionary and experimental approach to treating patients who had very difficult to treat, mostly hematologic or blood cancers and lymphomas. Due to advances in treatment, we have increased both the indication and then the types of transplants that have been performed throughout the last several decades. So it's estimated currently in the United States, there's about 25,000 patients who undergo a bone marrow transplant. For many of these patients, this is a last resort option. There are two types of transplants. Without getting into too much detail, autologous stem cell transplantation or bone marrow transplantation is when you receive your own stem cells back after you receive treatment. And then allogeneic is when you receive it from another person, and that's probably the one you hear about the most. So as I mentioned, there are different types of transplants, and those transplant indications have increased, and the number of transplants performed in the United States have increased. We also, due to better treatment strategies, we've had a very robust increase in the number of survivors. So the slide on the graph on the right essentially shows the number of long-term survivors of transplantation, and it's currently estimated about 250,000 survivors of transplant, and then that number will double over the next 10 years. So it's really a testament to the remarkable progress we've made in treating our patients. Next slide. But as the theme I think will emerge from the conversations today is that, you know, this improvement in survival, it isn't always equivalent. It comes with a cost. And when you look at these individuals 5+ years out, so once you make it past the transplant, you're a 5-year survivor. The reality is that your overall survival is substantially lower than what would be expected for the general population. And it's not the cancer itself that's causing the higher mortality, or what we consider premature mortality in this group. As you can see in the blue figure, the blue graph, is that it's really non-disease related mortality that's increasing. And so when we look at the next, if you can advance. When we look at the causes of late mortality, this looks like a busy slide, but I think the general concept here is that black is disease-related mortality, so relapses and recurrences. And on the bottom, on the x-axis, you're seeing the further out you are from your transplant. What you're seeing, as you would expect, is that the cancer-related, recurrence-related mortality decreases, and this is overtaken by other types of causes of mortality, including aging-related causes, such as different types of cancers and cardiovascular disease, pulmonary disease, etc. And these survivors have a much higher proportion of what we consider early onset or aging-related mortality, a premature mortality, accelerated aging type phenotype. Next slide. So this is just a very simplified figure of what we actually think is happening to many of our patients. And a lot of this really has to do with, as we study our patients, what we think happens is that during the treatment itself, as you can see in the gray bars, there is a change in the trajectory in this aging process. So all of us have a normal physiologic reserve that sort of holds us together, and that reserve declines as we get older. On the x-axis is time. What we think is that cancer and cancer treatment itself changes that trajectory, so that individuals are going to present aging-related conditions, present with aging-related conditions, and die of aging-related diseases at a much higher rate than what you would expect for the general population. So that's the general hypothesis. And why do we think that happens? That's in part when you actually look at, you know, the NIH convened a panel of experts to try to understand aging in the general population. Why does aging happen? Well, aging is essentially, you know, normal aging is maintained through these very important pillars. You know, the more inflammation you have, the higher aging-related disease burden, the more macromolecular damage, the organ tissue damage there is, the higher the risk of accelerated aging. And then if you can hit the next slide, the next, and what you can see is that if you overlay onto this cancer and its treatment with its multimodal approaches, whether it's chemotherapy, radiation, surgery, or bio or immunotherapy, it could really alter each of these pillars of the normal aging process. And why is this important? Because the more intensive the treatment it is, the more multimodal this treatment it is, the more likely it is to disrupt the basic fundamental processes that maintain normal, healthy aging. If you can advance to the next slide. So we're going to think about outside the box kind of approach of how do we think about aging, and are there other models of accelerated aging in the general population that have been well established, and can we use those models and approaches to study cancer patients and why they develop aging-related diseases? So let's take the concept of an astronaut. So astronauts have been studied for many decades now, in part because we want to understand not what happens to them during the immediate flight process, but what happens to them afterwards. If you can hit the next slide. So if you take an astronaut, and the reality is that there are multiple risk factors that put this astronaut at risk for premature aging-related conditions. And this is in large part driven by physiologic stressors that happen. These physiologic stressors happen in flight, whether they're direct related stressors, so microgravity, radiation, or indirect changes that happen in space, inactivity, weight changes. And if you actually study these individuals before and after space flight, if you can hit the next part, what you will see is that many of them, when they come back to Earth, have these physiologic changes that are mimickers of aging. They have cognitive impairment, immune dysregulation, cardiac issues, anemias. They have marked exercise intolerance, muscle loss, bone loss, and they actually come back physiologically aged. Now, they have an excellent reserve to go into space flight, so they recover. But let's think about that model of accelerated physiologic stressors and put that to the cancer patient. So if you can hit the next mark. What we see is that cancer patients also have multiple stressors that are there at the time of the cancer treatment. So they have baseline risk factors. They tend to be older. They may have a family history of specific conditions. Then we give them chemotherapy, radiation, biotherapy that is a direct insult to the physiologic reserves of an individual. And then many of our patients have prolonged inactivity during their cancer treatment. There are weight changes, there are metabolic diseases that emerge. And in our patients, for example, who are undergoing bone marrow transplantation, many of them are in bed for weeks, if not months at a time. So there's prolonged bed rest. And in fact, when you actually overlay this on top of what we would expect in other accelerated physiologic stagings, if you can hit the next button, what you see is very similar physiologic changes in our patients. So that, what we think is that is really the driver of why these patients are developing these health conditions. So if you can hit the next. So why transplant patients, and why do we think that this is accelerated in these patients, especially so? In part because these are the patients who have been treated the most intensively. So many of our patients who go to bone marrow transplantation are initially diagnosed with the cancer. Often they will relapse from the cancer, and then if you can hit the next one, they will then be referred to a transplant as sort of the sort of last ditch effort to try to cure them from their hematologic cancer. So the transplant itself is not without its sort of treatment exposure. You have chemotherapy, radiation, and then after transplantation, there are unique complications that can develop. Some of these patients will relapse again after the transplant, so they need additional therapy. So if you can think about transplant, it's really physiologically the most demanding type of treatment that you can give. So you would expect that in that case, you would have the highest amount of aging-related disease in this population. And in fact, Dr. Bhatia and others have actually shown, if you can hit the next slide, that when you look at these long-term survivors of transplantation, they are more than 8 times more likely to be frail, which is really the end stage of aging, than their siblings. And if you can hit the next button. What does frailty mean in this group? Well, if you become frail, you have a much higher likelihood of dying, and dying prematurely, compared to someone who is not frail. So it's especially imperative for us to understand why this happens to some people and not to others, but more importantly, to try to understand the biologic mechanisms. Next slide. Most of the work that I just showed you right now is really focused on what happens to people long-term after cancer treatment. Next. What we're primarily interested in understanding is how do we get people into transplant in better shape? How do we prevent these issues from happening? How do we understand and make decisions up front? Who is the person who's going to get into trouble later on versus who's going to skate through without any issues? So the work that we're talking about is really understanding the biology of aging during cancer treatment. Next. So when we've done some preliminary work looking at what are the markers of aging and how do they predict outcomes? And these markers of aging we've studied primarily before the cancer treatment is delivered. So what is someone's physiologic health before you even start the treatment? How does it impact outcomes? So sarcopenia is another marker of aging where all of us, as we age, we lose about 1% of our muscle mass over time. And this is 2 different configurations of sarcopenia versus no sarcopenia. Next. You can use existing imaging studies like CT scans to look at the people's muscle and their muscle health. And some of this, we can actually use existing imaging CT scans prior to their cancer treatment and predict who has sarcopenia and who doesn't. Next slide. These are 2 images from 2 individuals with who have the same age, same diagnosis, same gender, same body mass index. The only difference between the two of them, and this is a cross-sectional of the abdominal muscles, is that one has sarcopenia, which is loss of muscle with aging, accelerated aging, and the other doesn't. How does this impact outcome? Well, patients who are sarcopenic before they start their treatment have substantially worse survival compared to those who are not sarcopenic. After adjusting for everything, including age, comorbidity burden, diabetes, hypertension, all the aging conditions, physiologic health, physiologic weakness, and frailty are really important drivers, and you can identify this before someone actually goes to treatment. Not only is it associated with worse survival, next, it's associated with higher rates of ICU admissions, prolonged hospitalization, readmission, and non-relapse related mortality. Next. So short of scanning every single person before they start the treatment, are there simple blood tests that we can actually do to understand where somebody is on that aging spectrum above and beyond their biologic chronologic age? Because you could have two individuals, 65 years of age, who are going through treatment, but biologically, they may be potentially very different. So there's an emerging concept called clonal hematopoiesis, and that essentially just means that all of us, as we age, in our blood, there are specific genetic mutations that develop, and these expand over time. For most people, they really don't have much of an implication, but they can be surrogates of aging. And what I mean by that is biologic aging. Next. There are specific genes that are altered in the blood that are highly correlated with who biologically is older versus another person. Next. And interestingly enough, plenty of work has sort of emerged recently to show that if you have these blood genetic alterations, that you're associated with a higher risk of aging-related diseases in the general population. Next. We've done some preliminary work in our population at City of Hope. I'm not going to get into it too much time because I spent time in the beginning, but essentially to show that preliminarily, if you have this blood biomarker of aging before you go to your cancer treatment, you have a much higher risk of non-relapse related mortality, aging related diseases such as subsequent cancers, respiratory failure, multi-organ failure. So again, a simple blood test after accounting for all the other normal modifiers of premature mortality can help identify who's going to get into trouble, not just during the transplant, but long after. Next. So the V Foundation is helping us to look at these specific genetic mutations in the blood in our patients going to transplantation. We had initially proposed doing the genetic analyses in about 1,300 patients, and we've expanded that to nearly 2,000 patients with diagnosed with multiple myeloma and lymphoma. Next. We have done DNA extraction already in nearly all of them, and have done the library prep and sequencing to help identify the genetic mutations in these individuals, and over 1,000 of them in just a year. Next. And we're doing innovative strategies where we're linking large databases from our electronic medical record using natural language processing, which is an advanced way of querying millions of records, and then linking those health outcomes and complications in our patients with the upfront genetic mutations that we're seeing in our patients. Next. Ultimately, just as an update, we've done over 1,000 patients who've been sequenced to date. We anticipate completing the sequencing of the entire cohort by the year 2020, which would make it the largest cohort of patients that have been sequenced in the cancer population. Next. We're ultimately integrating that into a risk prediction model to identify who's going to get into trouble before you even start your therapy, which is really where we want to go. Next. And then we're going to explore additional associations with aging-related biomarkers. Ultimately, what we want to do is we want to be able to make personalized decisions up front. What is the optimal strategy? It's not just about curing, but it's about thriving. Next. This work would not be possible with the fantastic team of investigators and collaborators, and obviously without the support of the V Foundation and the patients and their families for their active participation. So thank you so much for your time, and I apologize for the glitches with the slides.
No need to apologize at all. Thank you. That was really interesting. And I love the analogy to to an astronaut and to what goes on in space. This makes it something we can all grab hold of and understand better. So thank you very much, Dr. Armenian, for your presentation. Okay, so we're on to our next presenter, who is Dr. David Gerber. Dr. Gerber grew up in Toledo, Ohio. He started working, he got a history degree and worked as a juvenile protection officer before beginning his career in medicine. He's now a medical oncologist specializing in lung cancer at UT Southwestern Medical Center in Dallas. And he's going to talk to us about the genetic mediators of immune-related adverse events. So Dr. Gerber, welcome.
Susan, thank you for the introduction and the opportunity to present my work this afternoon. Are you guys able to see the full view and hear me at this point?
Yes, thank you. All's
Miracle
good.
of miracles, great. So,
we're all learning.
It really is an honor to have received funding from the V Foundation. I've been at this work for close to 13 years, and getting that notification recently was really a career highlight for me. So by way of background, I think for this audience, unless you have been living under a rock for the past decade, you've heard something about immune therapy. These drugs go by various names, but most commonly immune checkpoint inhibitors, and they truly are field-changing for medical oncologists. One of the greatest revolutions we've seen in the last 50 years. They can be effective in so many different clinical situations, and now are probably already FDA approved for at least a dozen different types of cancer. But the elephant in the room, and something that is often overlooked in the enthusiasm of these agents, is their potential toxicity. And I think that's particularly concerning when we think about survivors and thrivers and what it might mean to have a potentially severe or permanent event as a result of this exposure. So immune-related adverse events, which I'll be abbreviating as IRAE in some slides, autoimmune toxicities. And unlike chemotherapy toxicities, these adverse events are entirely unpredictable. They may affect almost any organ. In some instances, they may be life-threatening. So my group and I hypothesize whether or not someone develops one of these toxicities really has to do with characteristics of the patient's immune system and their own genetic predisposition, rather than the biology of the tumor being treated. And so our project aims to determine these characteristics, ultimately allowing us to predict these toxicities so we can customize this treatment and monitoring for our patients. The toxicities of chemotherapy are usually easy to diagnose and are actually, Mr. Hamilton, I'm going to say something to you that I say to all of my patients after they've had their treatment. You have greater expertise than I do, because I've prescribed it to hundreds of patients with lung cancer. I've never received it. When we give chemotherapy in lung cancer, most often we're giving it IV once every. I can tell patients before they start that if you're going to have nausea and vomiting, with our regimens, it's most likely in the first week. When your blood counts are at their lowest, during the second week is when you might feel the most fatigued. And for most of our patients, they start to lose their hair after the second dose. Immune-related adverse events are entirely unpredictable. Who's going to get it, when it's going to happen, and how severe it will be. So this is an example of pneumonitis, or life-threatening inflammation in the lung. This is a CT scan or a CAT scan, and you just have to imagine that it's a slice through the patient's chest, lying on his back here, and his front here. This is his spine. These are the blood vessels coming out of his heart. And normally, each of these lungs would just be essentially black. showing air, as you can see outside the body. All of this whitish gray filling in is abnormal, and that's what led to the patient needing to go to the ICU. This is a patient who, after a few doses of immune therapy, developed a severe clotting disorder where the blood shut off to his fingertips, many of which he lost due to this side effect while being treated for melanoma. These adverse events are incredibly diverse compared to those of chemotherapy. They may affect almost any organ system in the body. I already gave you an example of the lungs or pneumonitis. There's also the eyes, the thyroid gland, pancreas, leading to GI problems, the joints, the muscles, the intestine, the liver, the skin, even parts of the brain. How do we manage these circumstances when they happen? Well, there is no dose reduction the way there is with chemotherapy or targeted agents, because it's not the drug itself that's causing the side effect. It's the patient's own immune system that is hyperreacting when these drugs stimulate it with the hopes of an immune attack on the cancer. But these events happen when that immune attack also spreads to normal tissue and organs. What's thought to be a clinical risk factor for this happening? If someone already has autoimmune disease, they already have lupus or rheumatoid arthritis or inflammatory bowel disease, it's felt that their immune system is already hyperactive, and so that's going to predispose them to have even more problems when you give immune therapy. And because of this, patients with autoimmune disease have been almost universally excluded from every single clinical trial of cancer immune therapy. So we asked, what we thought at the time was a pretty straightforward question: what percentage of patients with cancer have autoimmune disease as well, so might not be eligible for these highly promising therapies? Well, as you might imagine, some of the autoimmune disease ones that we saw, rheumatoid arthritis, psoriasis, lupus, ulcerative colitis, for example. But the actual prevalence of these diseases vary tremendously depending on how we looked in a national database called SEER, or Surveillance Epidemiology and End Results. If to identify a case of autoimmune disease, we only required one instance of a physician putting in a diagnostic code in the patient's chart, it wound up being 25% of patients. But if we were a little more conservative and we said there had to be at least two instances of the diagnostic code, it fell to 14%. And that was a reminder to me, that was a wake-up call, that it's actually pretty hard to diagnose autoimmune disease. In some ways, we have it easy as oncologists. A cancer diagnosis is usually based on pathology and a biopsy. It's a yes or no answer. But to diagnose someone with lupus is multiple clinical criteria, findings on a physical examination, some blood tests, some imaging studies, and there can be a lot of disagreement between physicians about which patients actually do and do not have some of these disorders. Thinking along those lines, it occurred to me that immune-related adverse events are autoimmune diseases we're causing with our treatments. I wonder if they're also difficult to diagnose. In this study, I asked two other physicians who are highly experienced with immune therapy to review 50 patient charts. And for all those patients, for each one I asked them, did the patient develop an immune-related adverse event? If so, what type was it? How severe was it, and when did it happen? And so on the left here, what you see is the two different clinicians, one in red and one in blue. And in some side effects, for example, on the lungs, there was a difference in the rate that was observed. So the physician here on the left thought it occurred a little bit more often than the one on the right. But for effects on the adrenal gland, which is an organ next to the kidney that has some hormonal functions in the body, they both agreed. They both said 8% of the patients developed this side effect. Well, then I actually looked at which 8% of the patients they were. And they weren't exactly the same patients, as you can see here. Only some of them were the same patients. And in other cases, one physician thought some patients had adrenal insufficiency, but the other didn't. This made me realize a couple of things. If I'm going to study the ability to predict immune-related adverse events, I better be really confident in who's actually getting them. So for our work, we now have at least 2 different physicians reviewing the clinical history of all the patients, and any disagreements are resolved in a group discussion. The other thing that it made me realize was that when I set out to do this work, my goal was to be able to predict who's going to get immune-related adverse events. Now I realize that some of our findings may even help us diagnose those toxicities. So what have we done? We have developed a study in which we approach and enroll patients and to start cancer immune therapy. If they agree to enroll, we start collecting their clinical data. We draw blood before they start immune therapy and then periodically afterward. We're trying to look at the genetics of these patients. We're looking at their immune profiles and also the molecular underpinnings of their immune system. And so far, we've actually been able to enroll over 300 patients. This platform has allowed us to study clinical events and biological changes over time. This is one set of blood we looked at in the blood draw before patients started their immune therapy. And we saw differences in these blood tests between those patients who didn't go on to get autoimmune toxicity and those who did. This is a really interesting case of a woman who developed an autoimmune side effect on her blood vessels, causing her fingers to get very white and painful in some circumstances. She actually didn't get this side effect until she'd been on treatment for more than 20 months. And we thought to ourselves, what is happening that she's cruising along just fine? We don't change the dose, we don't change the schedule, and all of a sudden this problem hits. When we look at substances in her blood called autoantibodies, or part of her immune system that might be attacking normal organs and tissues, it looks just fine up until a month before her side effect, and then everything goes haywire. In conclusion, while cancer immune therapy, these drugs that we call immune checkpoint inhibitors, represents a highly promising treatment, it may also cause toxicities that are permanent and to study the prediction and characterization of these events, we have assembled a large cohort of patients with serial blood samples for laboratory analysis. We have identified some biomarkers associated with the development of these toxicities. With V Foundation funding, we're now working to find the underlying genetic characteristics that may explain why some people develop these toxicities and some don't. And I really hope that this information may help us customize the administration and the monitoring of immune therapy so we can make this treatment even more available and helpful for our patients.
Thank you so much, Dr. Gerber. It's so interesting and so important for us to recognize what those pre-existing, immune compromising diseases might be doing to the treatment with these wonderful, but as you said, sometimes with some pretty severe side effects, immunology agents. So thank you very much for that presentation. We've got a short break scheduled, and then we'll continue with the rest of the presentations. It's my pleasure now to introduce John Thiel. John is a relatively new member of the V Board of Directors, and he's one of these folks who you think, how come I didn't know him forever? because I think anyone who has known John forever has probably had a much enriched life because of it. He is a delight to work with, smart as a whip, kind and caring and giving, and he's going to talk to us about the board of and the operation of Don't Ever Give Up, which is our support organization, but most importantly, what Thrivership means to us. John, over to you.
Thank you so much, Susan, and I really appreciate the opportunity and enjoy listening to the research that's being done. It's so hopeful, and yet so much more to do as you think through all that we just heard. I've been asked just to get to talk a little bit about how I got involved and why I got involved, and the why is pretty easy. Cancer is personal for everyone, and I met my wife many years ago, now married 37 years. And on our second date, she began to talk about her dad, who was battling cancer. And as it turns out, it was pancreatic cancer. And in 1982, while it's still difficult now, there was virtually no hope. And 2 months later, I made the drive home with her 7 hours to her father's funeral. And when I got there to begin to spend time with her family, I saw her mother, who was 46 years old. She had a son in law school, a son in vet school, a daughter in college, a daughter in high school. The love of her life had just died at age 50. And it just really struck me. What didn't strike me at the time, though, was the long-term impact of losing him on the family, really up until this point, and being such an important figure in their life. And then it really began to bother me that in my mind, whether it's right or wrong, it didn't seem fair. And the impact was so outsized when mothers and fathers and so many others and children passed. So I was always keen to try to do something. It wasn't until I went to New York that I got involved officially in trying to help do something. I chaired a gala in New York where the financial services industry, which I was part of, was running Merrill Lynch. Really got together after the crisis, and we really started to try to raise money and try to impact cancer research, primarily in the New York area. At the same time, I was exposed to the V Foundation through a friend of the V and a board member, the Hall of Fame announcer, Dick Vitale. Now, if any of you know Dick, Dick is an incredible personality, an incredible person. He and his wife, Lorraine, are tireless. He has hosted a huge fundraiser in Sarasota, close to where we had a second home in Florida. And I began attending that because he was a very good client and a friend of ours. And I got to know a little bit about the V Foundation. But being busy at work and doing the work I was doing in New York, I didn't have time. Dick figured out that I was going to retire in 2017. And in only the way that Dick Vitale can do it, in the middle of a motivational talk that he was giving to our advisors, I had hired him many times. He stopped, as he typically does, in the middle of a story and goes on a divergent path. And this time the path was to point to me and say, "You need to be on the V Foundation board." Well, it was a challenge that I don't know that he realized what it meant. But afterwards, I said to him, "You know something, I would like to learn a lot more about the V Foundation, because 100% of every dollar raised for research goes to that research. And we have this brilliant scientific advisory committee that decides where the money should go and where its greatest impact is, and maybe most importantly, measures the outcomes and monitors the progress so that we know as donors and people working to raise money that the dollars are being used as appropriately as possible. And then obviously the impact. One of the things that's important for me is that if I'm going to give money to something, that they have to accept my sweat equity as well as my financial equity. And what I didn't realize at the time is how good Susan is at asking for me to provide that sweat equity. And it wasn't long before I was on the board that they asked me, because of my relationships in New York, to see if we could get an event going in New York. Because candidly, the V Foundation has low awareness in the city of New York. While we have the great hospitals and the research centers, the V Foundation wasn't well known and didn't have the reach. And could we do something? They had had a breakfast with Robin Roberts, a longtime board member, and obviously a wonderful woman and a huge celebrity in New York City. And she had offered to think about how we might help on this issue of thrivership. And in talking to her and understanding her and so many other people that we know that have survived cancer, just the idea of dealing with what we're hearing about medically, but also emotionally, with waking up every day wondering, wow, what a great idea. If we could get behind each other and have Robin's support, could we create an event? And we did. And we're fortunate now to be in our 4th year. We've had successive growth in that event with that focus on thrivership. As Susan mentioned, last year we gave our first Thriver Award to Scott Hamilton, who we so appreciate. And of course, Robin being out there and leading has been so important. None of it would have happened if it weren't for the generous support, really, of Bristol Myers Squibb. Mark Peters mentioned that earlier, and they've been so generous and been part of the event the entire time by attending it and supporting us in so many ways. But to me, the Thrivership makes so much sense because we grieve the people we've lost, but we've got to stay here and fight for the people who have, 16.5 million people who have, successfully come through their cancer treatments and are looking to live the kind of life that Scott described in his piece. So I'm thrilled and excited to be involved as a board member. I chair our Don't Ever Give Up support organization, where a lot of our event fundraising goes through. We spend a lot of time doing that, but we're also thinking about how we can innovate, how we can broaden our reach. And for all of those on the call, if any of you have any ideas on how we might be more effective at that, I'd love to talk to you about how we could do that. So as I mentioned, this event in New York has really made a lot of progress and gotten a lot of notoriety. And again, that really is really due to Robin's involvement, as well as the generous support of ESPN and ABC and Scott Hamilton and Bristol Myers Squibb. And I thought maybe it would be great to end this as we think about what we're going to hear from the other doctors coming up, is to see how that manifested itself, that event, and Robin's willingness to share the work that we're doing in a segment of Good Morning America. If we could please show that clip.
Hey, big welcome back to GMA. And I gotta say, we have a great audience with us on this Tuesday morning. And we got a little surprise for the eyes.
Yes?
Mr. Scott Hamilton is here.
Yeah.
In the front row. The legend.
The legend lives. And you know why he is here? Because last night it was a very special event. I have this Thrivership Fund through the Jimmy V Cancer Research, and he was our first recipient for the Thriver Award, Scott Hamilton. And it was such a special night. You are just an absolute legend, and everybody that was there. We raised $700,000, over $700,000. I can't thank you enough. But let me ask you, Scott, real quickly here. You've talked about, I mean, you're a phenomenal skater, and you've talked about how facing cancer even made you stronger. How's that?
Oh, I don't know what my life would be without it. I lost my mother to cancer, which kind of woke me up and allowed me to kind of dedicate myself towards her, to be the person that she always thought I could be. Mm-hmm. And then 20 years after I lost her, I was diagnosed, and I had to wake up again, and this time try to truly understand the disease and how to better fight back for not just me, but for everyone. And so we're working very hard. We partner with the V Foundation,
yes.
and they are an extraordinary organization, and they're elevating cancer research like no one else. So we're just proud as My Cares Foundation to partner with them, and thank you so much for inviting me. You were up late last night.
I know. Thank you for reminding me. But we don't give up. We don't ever give up.
Never.
James, thank you very much. Jane, with the wine festival that you have out in Napa, which is just bonkers. And we call ourselves Thrivers, not Survivors. And so anyone who is a Thriver here, you're going to get a pin too. I know we have some Thrivers in the audience. Thank you to the V Foundation.
There you go.
Yeah, so very, very proud.
So Susan, thank you, and I'll turn it back to you.
Okay, thank you very much, John. That's great. And who cannot love watching, Good Morning America and Robin talking about the work that we do and seeing so many of our friends there, Jim Ryan from Constellation there and his wife Cecilia right beside Scott, and our friends from the wine celebration, our friends from BMS, Bristol Myers Squibb, who were in the photo. It was just an awesome time and really helps us remember what survivorship means and think about what it is to thrive. Well, our next guest, our next speaker, is Kevin Kroll, who is on the faculty in the Epidemiology and Cancer Control Group and has the endowed chair in cancer survivorship at St. Jude. He has expertise in neuroscience, clinical neuropsychology, and biological psychology. And he's going to talk to us about the cerebrospinal fluid biomarkers in long-term neurocognitive and brain imaging adverse outcomes in survivors of childhood lymphoblastic leukemia who have been treated with chemotherapy. Welcome, Dr. Kroll.
Let me say thank you to the V Foundation for inviting me to present my research, and I'll jump right into it. So the purpose of my research related to the V Foundation funding is really twofold. First is to examine protein profiles in cerebral spinal fluid at diagnoses and during chemotherapy for childhood acute lymphoblastic leukemia. And then second, to evaluate the associations between these protein profiles and neurocognitive and brain imaging outcomes that occur later. Protein patterns in the CSF may help us to identify mechanisms leading to brain injury in the ALL survivors. And if we can understand these mechanisms, we may be able to treat, or more importantly, prevent this brain injury from occurring. So let me start by talking about the evidence that reflects brain injury in long-term survivors of childhood ALL. This table comes from an investigation of roughly 212 children with children and adolescent survivors of ALL treated with contemporary chemotherapy-only protocol. At roughly 5 years following the completion of treatment, a significant proportion of the survivors demonstrate cognitive impairment, particularly in the areas of executive functions, such as flexibility, cognitive fluency, working memory, and organization and planning skills. These problems are persistent and limit future educational attainment and employment in the survivors. This cognitive impairment is associated with altered activation in frontal brain regions. Here you can see images of the frontal of the brain during active task completion. You notice in the frontal lobes, there are areas identified in green that demonstrate overactivity in survivors with cognitive impairment compared to survivors without impairment. We believe these brain regions are overactive because they're less efficient or less developed, and they're working harder to try to accomplish a given task. These frontal regions are likely working harder because they've not developed the same level of connectivity in neural networks or circuits throughout the brain. Here we can see 4 commonly identified neural networks represented by different colors. The color of the dots represents the common network, and the size of the dots represent the strength of the connection of that region in that given network. The brain image on the left is an average of roughly 100 survivors without cognitive problems. You can see clearly, you can identify all 4 networks, common networks, in the non-impaired survivors. The image on the right is an average of roughly 75 survivors with cognitive impairment. Notice the lack of a well-developed executive attention network, the light blue color, which you can't really see in the impaired individuals. This finding demonstrates a lack of development in this network, and thus the overactivity in the impaired cognitive function displayed in the previous slides. We're interested in identifying the mechanisms that underlie or interfere with the development of these neural networks so that we can eventually learn how best to facilitate healthy development of them. We began this quest by examining protein concentrations in cerebrospinal fluid of children prior to and during chemotherapy for ALL. This fluid is easily accessible during routine diagnostic testing and prior to intrathecal administration of the chemotherapy they routinely receive. We started by looking at concentrations of 4 proteins that signal the general health of different types of cells in the brain: astrocytes, neurons, and oligodendrocytes, which make up the myelin or the insulation on the axons of the neurons. we found that at diagnoses prior to chemotherapy, myelin basic protein from the oligodendrocytes was elevated in the CSF, suggesting that something related to the leukemia itself may be injuring the myelin that coats the axons that develop the network connections in the brain. After intensive chemotherapy treatment, nerve growth factor and tau protein increase in concentration, suggesting injury to the neuronal cell bodies and the axons themselves. This injury seems to occur within 2 months of starting the chemotherapy and likely results in the reduced network connectivity that we see later on. However, knowing when the injury occurs doesn't really help us identify the mechanisms underlying the injury. And we couldn't really identify or determine this mechanism from the small number of proteins we examined. To move this research forward, we were fortunate to secure the funding from the V Foundation to examine the entire proteome of the CSF. This proteome is the entire complement of proteins in the CSF. It can be comprised of up to 4,000 different proteins. Comprehensive assessment of the proteome content in the CSF at different times before and during therapy could inform us of mechanisms underlying the injury to the myelin and the neurons that we're starting to see. This is a complicated and time-intensive process that includes quality controlled protein extraction, protein digestion, peptide desalting, tandem mass tag labeling, and ultra-deep high-performance liquid chromatography. All of this work is done in our mass spectrometry shared resource in the Comprehensive Cancer Center of St. Jude Children's Research Hospital. The process that we go through generates a spectrum that identifies protein signatures. You can see them here reflected along the horizontal axis, each one representing a different protein, and concentrations of the protein reflected along the vertical axis. The process is conducted on CSF samples collected at diagnoses prior to any treatment and after intensive chemotherapy, with comparisons within patients run in batches to control potential fluctuations in internal references. Although we're still running these batches of samples, we do have some preliminary observations from the samples that have been processed on the first set of survivors. We've obtained good quality CSF with minimal contamination of blood. This is always a concern because the CSF has to be extracted from the spinal canal. Tandem labeling has progressed quite well, and liquid chromatography and mass spectrometry have identified nearly 2,500 peptides and 500 proteins in each batch. We're seeing the same 1,332 peptides and the same 339 proteins in all the batches that have been run from the different survivors so far. We've also been able to quantify the same 339 proteins in all the batches run to date across survivors. This will permit us to examine the associations between the presence of over 1,000 proteins and the change in concentration of over 300 different proteins over the course of therapy. This is a significant jump in our previous research of only 4 proteins. Knowledge of these proteins and the changes will be examined in association with the neurocognitive function in the brain imaging studies I presented previously. Although we're still running batches, we have already begun to see statistically significant changes in protein concentrations from diagnoses to post-intensive chemotherapy in the survivors run to date. And you can see these listed here in this table, showing significant differences in survivors. The initial pattern that looks like it's beginning to emerge is significantly increased inflammation in proteins that come from systemic inflammatory processes, as well as inflammation in central nervous system processes in the brain. With these processes, again, beginning within 2 months of diagnoses. I have to reiterate that this is still preliminary and we need to complete our assays on the remaining survivors. This is a smaller subset than what we'll initially complete. Survivors are also in the process of completing neurocognitive testing and the brain imaging testing that I demonstrated earlier. Still, this is a very promising start, and we hope that this will inform us as to how to intervene with these survivors to prevent the suppression of brain maturation that we see in the long-term outcomes. And hopefully we can facilitate and help these survivors thrive with enriched brain function, enriched educational attainment, enriched employment down the road. With that, I'd like to thank our survivors and the clinicians that treat them, as well as our funding sources, including the very important funding that we received from the V Foundation. Thank you.
Thank you so much, Dr. Kroll. That's also another interesting presentation. It shows us the far-reaching effects of therapies over the years, so thank you so much. Our next presenter is Dr. Ellie Papa-Emmanuel, who is at Memorial Sloan Kettering Cancer Center. She's a molecular geneticist who looks at systematic interrogations of well-annotated clinical trial cohorts in leukemia and other cancers to explore the compound genetic and clonal architecture in patients' leukemias and their tumors to help dictate the clinical phenotype, disease progression, and clinical outcomes. She works with a great multidisciplinary team there at Memorial, and she is going to talk to us about the impact of oncology therapy on clonal hematopoiesis, which we heard a little bit about earlier, and then the subsequent risk of developing a therapy related to leukemia in cancer survivors. So Dr. Papa-Emmanuel, welcome.
Hello, thank you so much for the invitation and the opportunity to be here today and present on behalf of our team at Memorial Sloan Kettering Cancer Center on a very important topic that has been enabled by the V Foundation. And I would like to say that it's really inspiring to hear the talks today and to see that so much research that is being supported that extends beyond the realms of how we can optimize, not only how we can optimize primary cancer care, but most importantly, how can we think holistically about our patients and how can we account and improve the treatment, taking into account comorbidities as well as long-term risks. So very, very appreciative of your support. So a major foundation on our understanding of cancer development, at least from a molecular perspective, is that cancer is very much the end result of a stepwise acquisition of acquired mutations. So what happens is a normal cell will often acquire a mutation that will give that cell fitness over other cells, and it would allow it to expand as a uniform cell population. And what we do understand is that in the vast majority of cancer types, there is a stepwise acquisition of mutations that parallels very much the principles of Darwinian selection that results in populations of cells that have acquired mutations that can invade their local environment, resist treatment, and ultimately result in metastasis. So in recent years, molecular profiling studies have allowed us to understand that for all of us, as we live and breathe, our probability of acquiring these mutations across any tumor or any tissue type in our body increases over time. And usually those mutations really do not have any consequence. But if they do hit the right gene in the right cell at the right time, then they will lead into this first clonal expansion. So in recent years, there's been studies that focus on sequencing normal tissues in order to understand how these processes happen, and most importantly, understand what other potential exposures or environmental parameters may stop a cell with a particular mutation from growing and allow another cell with a particular mutation type to expand. So these are parameters that may increase selection and fitness of particular cells. Now, as we heard earlier, the acquisition of mutations and the establishment of a clonally expanded population in the blood is referred commonly to as clonal hematopoiesis. Studies in the blood have been the most advanced because it's very easy to sample blood. So we're starting to understand this phenomenon very well. And population studies by Ben Ebert groups, as well as others, have shown that the incidence of clonal hematopoiesis increases with age. And if we look at this incidence curve over time, it very much reminds us of the incidence of cancer. And in fact, both cancer and clonal hematopoiesis have this shared age-related incidence, with the peak really being at individuals of the age of 60 or 70 years old and greater. So we asked the question as to what is the impact of CH in cancer patients. And this is important because we know that a major complication or cause of mortality following treatment in cancer survivors is the development of therapy-related myeloid neoplasms, or TMN, as indicated here. And therapy-related myeloid neoplasms constitute 10 to 20% of all primary myeloid leukemia diagnoses. They affect about 0.62 patients per 100,000 patients. And the survival is actually very dismal. And in fact, therapy-related leukemia is considered to be one of the most lethal cancers amongst all cancers. Here we see that the incidence of therapy-related leukemia can vary by treatment type, but the majority of the survivors, for example, the largest proportion of the absolute number of patients with therapy-related disease come for some of the most frequent cancers, such as breast cancer or non-Hodgkin lymphoma. And this is important because as we get better at treating the primary cancers of patients, we now have about 13.7 million cancer survivals in the United States, and this is expected to rise to 18 million. So I should also say historically, it was thought that oncologic therapies such as chemotherapy and radiotherapy during primary treatment caused additional mutations or new mutations in the blood, and that those mutations led to the subsequent development of therapy-related leukemia. However, as we appreciate the phenomenon of clonal hematopoiesis and and the fact that individuals with clonal hematopoiesis in normal populations are at an increased risk of developing myeloid leukemias, we try to ask the question as to what is the effect of oncologic therapy in clonal hematopoiesis in determining the risk of therapy-related leukemia in cancer patients. And in many ways, we were uniquely positioned to ask this question because at MSKCC, every month, about 800 to 1,000 new patients who get onboarded into our hospital will be consented for tumor profiling using our in-house assay, MSK Impact. And part of that diagnostic process is to sequence the tumor as well as the blood in order to provide the oncologist with a report for the mutations that are present in the tumor of that patient in order to inform optimal cancer care. However, part of this diagnostic workflow means that data across a panel of just under 500 genes is also being generated for the blood, and that very much gives us the opportunity to go and study clonal hematopoiesis in our cancer patient population. So the study, generously supported from the V Foundation, allowed us to look at the first 24,000 or so patients that have been sequenced with MSK Impact, of which 10,000 patients we were in a position to extract very detailed treatment, demographic, as well as behavioral information such as smoking. We showed that 1 in 4 patients in our center are actually carriers of clonal hematopoiesis at the time that they come to receive treatment. And then we asked the question whether Clonal hematopoiesis is more frequent in patients that have received prior treatment, say those that may have been referred from another hospital. And indeed, we found that clonal hematopoiesis was more frequent in patients that had received prior treatment. But what was more striking, shown here in orange bars, was that patients that had undergone oncologic therapy seem to have clonal hematopoiesis with a very particular type of mutations, such as mutations in P53, CHEK2, or PPM1D. And this is important because these genes are part of a machinery in our cells that make sure that we repair DNA damage. What our ability to link very detailed treatment data with our molecular data allowed us to see that, or to find that clonal hematopoiesis was more frequent when patients had received particular types or classes of chemotherapy. For example, even amongst platinum agents, we found that patients who had received carboplatin as opposed to oxaliplatin had a lot more clonal hematopoiesis than the ones that didn't receive this type of therapies. And in fact, we also identified that there were dose-dependent effects, whereas the more treatment a patient received, the more likely the risk of being CH carriers for those patients. We also were in a unique position to obtain serial samples during the clinic primary care for those patients, for approximately 500 patients. And these were distributed between patients that didn't receive therapy between the two sampling time points and patients that had received an array of these different therapeutic regimens. And here we show the dynamics, the changes of the number of cells that may carry those mutations in the blood between the two time points. And we indicate in red when those cells expand, in blue when they contract, and in gray when they remain stable. And what we identified was that in patients that received cytotoxic therapy and radiation therapy, there was a lot more expansion of those cell populations in the blood whilst they were undergoing the primary cancer care therapy. And in fact, when we studied the type of the mutation that may have defined those type of cell populations, some patients may have had mutations in, say, in genes such as DNMT3A, TET2, which are very frequent in the population, and in fact the most frequent genes in clonal hematopoiesis. When we compared whether those cell populations expanded or not during therapy, we see here that there is no difference between the blue boxes and the orange boxes. However, in the patients that had clones or cells with mutations in one of those three genes involved in DNA damage response, the individuals that received therapy in orange in between the two sampling points expanded at a much greater rate than the ones who didn't receive therapy. So this shows that patients that may have had mutations in these genes not receiving oncologic therapy kept those cell population more in check or at more stable levels than the ones who did receive the therapy. So this allowed us to add a layer of our understanding in that therapy-related leukemia may not be necessarily directly caused by mutations that as a consequence of treatment, but in fact that it could be a result of a selection and an expansion of cells that already exist at the time of diagnosis. And then following subsequent additional genetic and clonal evolution, those cells go on and develop into the therapy-related neoplasm. This, of course, allows us to understand what are the critical pathways that define those cells. And in fact, the fact that we understand that now the cells that go and seed this therapy-related leukemia are defined by components of the DNA damage response machinery allow us to understand that the reason this tumor, this leukemia is so lethal is because the very genetic makeup of those cells expands and thrives in the presence of treatment. And it allows us to explore therapeutic avenues that target that particular biological pathway. However, beyond targeted therapies, we then ask the question whether this knowledge, given that we may be able to identify which patient at the point of care may be a clonal hematopoiesis carrier, is there anything that we can do in order to decrease the risk of this subsequent leukemia? So we modeled what are the risk factors that might predict for subsequent development of therapy-related leukemia. And we found that the presence of CH, the number of mutations, and most importantly, the type of the mutations, such as mutations in P53, are strong predictors of subsequent development of therapy-related leukemia. So with this in mind, we tested a scenario where now a patient at presentation, given example of this patient is a 72-year-old female, presents at MSK with an early stage breast cancer and is discussing therapeutic options with her oncologist. One of them may be a more a therapeutic protocol that has less treatment intensification and a wait and watch approach where surveillance may be implemented in order to check for recurrence of breast cancer. The alternative option is to increase the intensity of oncologic care to ensure that there's no recurrence of this breast cancer. However, now we know that this patient has a P53 mutation in the blood. And we know that if we were to administer intensive therapy in this particular patient, we might accelerate that clone in the blood and might increase the risk of developing a much more lethal disease than potentially the recurrence of an early stage breast cancer. So we modeled this in a breast cancer patient to see if we were to develop risk-adapted treatment decisions at the time of primary care, is there an opportunity to decrease the likelihood of developing therapy-related neoplasm down the line for the patients most at risk? And in fact, what our model showed was that in the patients most at risk of therapy-related neoplasm, we could decrease that risk by 8% without affecting their overall likelihood of survival for their primary cancer. So this sets a framework for the design of future prospective clinical trials to allow us to formally validate this inference and test it. But at the same time, at MSKCC, we formed one of the first clonal hematopoiesis clinics where we can identify patients at high risk with CH, at high risk of therapy-related disease, and bring them into the clinic and offer surveillance protocols and work with our teams in order to understand this better. So with that, I would like to thank the patients and the families, the V Foundation, for being the primary supporter of this research project that has now led to many more projects within MSKCC. This is really a true representation of many centers from our hospital, and Kelly Bolton, who drove this study, as well as everyone else in the group and in the lab. Thank you so much.
Thank you so much, Dr. Papaemmanuili. That's, again, excellent work, and we're delighted to know that it is leading on to further studies. A huge accomplishment. Thank you. We move on now to the last speaker of the afternoon, certainly not the least, Dr. Ann Partridge, who is at Dana-Farber Cancer Institute in Boston, is going to talk about young breast cancer survivors. And I just want to say Dr. Partridge is one of the beacons in the breast cancer world among young survivors. She is well known to them for her compassion in this work and being a great communicator of their needs. So welcome, Dr. Partridge, and thank you for being a part of our symposium.
Thanks for having me. All right, thank you so much to all of you for sticking with us this afternoon, and I'm last but not least, thank you for that. It also is fantastic that you set the stage the way that you did, because I too am going to talk about clonal hematopoiesis of indeterminate potential, or CH or CHIP, and I'll talk a little bit. Thank you to the prior speakers. Your work is fascinating and it's exciting to hear. What I'm going to present on is our study funded by the V Foundation. Thank you to the V Foundation and all of you who are listening and supporters, looking at clonal hematopoiesis in young breast cancer survivors, the prevalence, clonal evolution, and the association with clinical outcomes and late effects. I think we heard it well from Scott Hamilton earlier that, you know, you get this cancer, it's super unfair, it's devastating in many ways, and then now you have you're a cancer thriver or survivor, however you want to categorize yourself, but unfortunately it's a risk state, and cancer survivors are at risk not only of cancer returning for some time for many, even in highly curable situations, but also of long-term side effects from their treatment. This is what you heard I focus on. I'm mostly a clinician and I do clinical epidemiology. And what we try to figure out is, you know, which long-term effects can we prevent, can we foresee, can we mitigate when they occur? Because some of these long-term effects may be life-threatening, such as heart disease and other cancers or therapy-related neoplasms, as you've just heard a lot about. And we're always looking for ways to identify ways to who's going to get them, and maybe we can pick different therapies for them, as you just heard, or how can we reduce these risks, perhaps with other strategies, with drugs, with behaviors, and then again, how can we predict these risks so we can be ready if people are going to have those problems? And certainly, obviously, prevention would be better. So you heard about CHIP, or clonal hematopoiesis. Some people develop changes in their blood cells. This is called CHIP, and that's when survival of the fittest, as you heard earlier. One cell goes a little rogue. Usually it can be contained, but as people age, there's a selection that happens where more cells with particularly fit mutations dominate. And people with CHIP are at higher risk because of the mutations that they have in those cells, are at higher risk of developing serious problems like blood cancers, as you heard about, just baseline without any prior cancer therapy, and heart attacks and overall mortality. And the prevalence goes up as people age. So that case we just heard about a 70-year-old, it's not surprising that that person might have CHIP. She had about a 1 in 10 chance of it. CHIP is also found more prevalently in cancer survivors. And I've had the privilege for this particular project to work with my colleague and old friend Ben Ebert. As you heard, his lab helped discover CHIP, and he's now the chair of medical oncology at Dana-Farber, and he's one of the collaborators, he and his lab, on this. People with CHIP have a greater risk, not only of the therapy-related neoplasms that you heard about, but also of heart disease and heart attacks in particular. And here are some of the data that show this. If a person has a mutation in a particular gene, here the ATVB, hang on one second, I can't go forward with this, then they have a much higher risk of having a heart attack at a young age. And you can see that's where the arrow is, the odds ratio going to the right of 1 suggests a higher risk. This is also true with other mutations, as you can see here. So there's an overall 4-fold increase, as shown in these data, from having a particular mutation of having a heart attack if someone has CHIP. Now, why might that be? So it's not just about secondary leukemias or getting leukemia to begin with, or myeloid neoplasms. And very exquisite lab and mouse modeling studies, including gene expression studies, have shown that CHIP mutations are associated with accelerated atherosclerosis, which is basically the hardening of the arteries. And that's due to an inflammatory state within the coronary arteries of the heart. And these effects, we think, are due in large part to alterations in those blood cells, in the white blood cells that come out of the altered stem cells. And these can directly conferred by the mutation, they can promote increased inflammatory signaling that can lead to increased risk of heart attacks. So CHIP can lead to increased risk of heart attacks through that mechanism. I love showing mice in my slides, even though I'm the furthest thing from a basic scientist. Cancer survivors with CHIP also have a greater risk of therapy-related malignancy and mortality, and presumably heart disease, although this has not been shown quite as well in cancer survivors to date. Much remains unknown, though. So there are many questions. One of the things we don't know, although I did like that MSK data just now that you showed, is that we really don't know how common CHIP is in your average cancer survivor. We know it increases with age. We know that a lot of treatment is associated with having a higher prevalence of CHIP. And some of that also has to do with, you can find CHIP if you sequence deeply enough for it. But what is the threshold above which CHIP matters? and how much CHIP is enough to make it a problem versus just having it and it would be a bystander. Who's at greater risk for having bad CHIP? When does it develop? You just heard there's more and more evidence that we think CHIP is a problem that's already there in many patients because they aged, but then it's brought out with therapy. But what about any younger person? What about a 30-year-old or a 40-year-old? How frequent is CHIP in that person? Well, we think it's kind of low, but once they get treated for cancer, and of course we know our younger patients are more likely to get more aggressive therapy in many diseases, including breast cancer, which is the disease I focus on. What's the prevalence of CHIP in that population, and what does it mean for that person's long-term health, not to mention their risk of secondary malignancy or cancers, or heart attack. And if and when should we be looking for CHIP in the kind of cancer care trajectory of that survivor? And then finally, what should we do about it when we find it? We also have opened a CHIP clinic at Dana-Farber, and the first time someone told me about it as a clinician, I said, okay, are we going to have a couch in there to help people deal with the anxiety that we're not even sure what we should be doing about this? That being said, we should be looking, and knowledge is power, I think, but we have to think hard about how we support our patients when they learn this information about which there's so much unknown. But I think we are finding it more and more commonly with genetic testing that's being done as other parts of care, as you just heard in the prior speaker as well. So we need to deal with it once it's out there. And of course, if we know someone's at higher risk of having a future problem, we want to figure out, how do we tell them, how do we support them, and what do we help them to do about it? We want to help these patients to understand their risks as well as to potentially support them to reduce their risks. So our study is the overarching hypothesis looking at CHIP in young breast cancer survivors. And again, a group that's not supposed to have it because they're not old, but they probably develop it because they got cancer-related therapy or cancer therapy, is that CHIP will be enriched and associated with adverse outcomes that may be mitigated or prevented in the long term in a large cohort of young women with breast cancer that my colleagues and I have been running for the last 15 years. The first aim is to determine the prevalence and mutation spectrum of CHIP and its association with patient and treatment characteristics and outcomes in this cohort, because we don't know this answer. So we take young, healthy people predominantly, we give them chemotherapy, hormonal therapy, radiation therapy, smart drugs, some combination of the above, and what is the likelihood that they will develop CHIP, that it will become evident as a marker of future potential risk? We really don't know the answer to this. We want to characterize the clonal evolution and inflammatory correlates of CHIP in this population. And then finally, as we do this really exquisite translational work, which of course the Ebert Lab and my colleagues are leading, how do we help our patients once we share this information with them? How do we share it? So we're doing work now and find some really interesting findings so far about how do young survivors feel when they're told about CHIP, this thing that they probably never heard of, and the potential result delivery. If we tell you you're tested positive for CHIP after you've just been through a breast cancer, does that help you or does that hurt you, especially if we don't have something to do for you? And as we develop things to do for you, where's going to be the tipping point where it kind of makes sense for you to be more engaged with it, and we might push it on people as opposed to just offering the information if they're interested. It's related to kind of genomic genetic testing, like testing for BRCA1, BRCA2, P53 in the germline, but it's different because it's not something that you would inherit for your family. Well, it might be, but it's for the most part not, and something that it's really for that person to help understand their risks. And you can understand, and we've heard from our patients in our initial focus groups, that some of them are all in and want to know everything, but then there are some survivors who are kind of, I'm not sure if I want to go there right now. I've already been traumatized by cancer diagnosis and dealing with survivorship. And if I'm not sure what's going to help me, and more information for this person may not be the best thing at that time. So we're really trying to get at the patient preferences surrounding the sharing of such information and the potential kind of unintended consequences of these kinds of information being shared, and how do we best support our patients. And we've got a terrific group of patient advocates who are helping us with this work as well. So in sum, we hope this research leads to findings that can be used to not only understand this problem of CHIP better, but to improve how we take care of cancer survivors both now and in the future with regard to this really important biomarker of future risk. Thank you. And thank you to the V Foundation for all of your support.
Thank you so much, Dr. Partridge. We, as I said at the outset, really appreciate what you are doing, and especially for our young survivors. I mean, that is an incredibly changed field in the last 20 years, and you have been a big part of that. So we're very grateful. Thank you. But now just for a few questions, if we could go to the gallery view. And the first question that I think is for all of you is, how has the pandemic affected what you're able to do both in the lab and with patients? And I realize that could take us the next 4 hours, but a couple of heads up, and what you've seen would be very interesting to all of us. Okay, let's start with Anne. You want to start for us?
Do you want to call on us?
Yes, I'll do that.
So I think we actually did get slowed down. In part, one of the reasons I'm not presenting any of our preliminary data right now is that because of the shutdown and the fact that we were a hotspot up in Boston, we were prepared to have all of our DNA extraction was done, but our sequencing was not done yet, and then we got shut down and the labs got shut down, so lots of papers were getting written, but nobody could go into their labs and do their work until about 2 weeks ago. So we're moving along from that standpoint. The nice thing is that we had already done our focus groups, and we've created a survey that we're sending out to our young women in our cohort about their preferences. So the work continued, but we had a little bit of a glitch there because of COVID. In the greater scheme with patients, you know, it's been kind of an amazing revolution in virtual care, where we've done tons on video to take care of our patients. And then, of course, some patients still need to come in and get treatment. So we doctors are going in and doing shift work in the clinics, social distancing, and going in for the patients who really need to see us physically, and also taking care of our colleagues who can't go in because they may be in a higher risk group. And they can only do virtual. So that's kind of the way it's worked in Boston, I know.
Okay, thank you. Kevin, do you want to talk to us a little bit about what you've seen?
Well, we're in a similar situation where we shut down all clinical and basic science research up until a couple of weeks ago. Obviously, we didn't stop clinical care. Basic science research just started up 2 weeks ago. So even though a lot of our research is involved in just running assays without human contact, really, we were forced to just shut down the research, keep the researchers out of areas, and reduce the contact and exposure between researchers. So we're just getting up and going now. So that delayed us for a good 3 months, I think. But we're up and going now. Our clinical research has still not started up yet. Patient research, ancillary studies. We anticipate that to start up in August or September. Unrelated to this, in the meantime, we've engaged in surveys of patients to see how patients are adjusting. We developed a little COVID survey that we collected from about 5,000 of our patients, just to see what their emotional reaction was, what their stress levels were, et cetera. And we're in the process of analyzing that. So it did lead to sort of an unexpected research project during the shutdown.
We'd love to hear the results of that, because it's important for us to let people know what this means. I mean, clearly COVID is huge and what's going on with the pandemic, but it's going to have both immediate and long-term effects on cancer patients and their outcomes as well. I'm concerned. Dr. Bhatia?
So very similar to Anne and Kevin, our work had to slow down just a bit in terms of having our patients come in for research, but we really retooled it so that we were focusing more on analyses of the data that had piled up thus far, writing papers, asking new questions, and similar to Kevin, really trying to focus on what was really troubling our cancer survivors and thrivers in terms of the COVID pandemic that was ongoing.
Thank you. So David, what are you seeing?
Susan, the impact has been pretty profound on our research. We had a period of almost a month where we did not enroll any patients to any type of clinical trial. About 2 months ago, we started reopening our trials, but we've limited it to therapeutic clinical trials where we're giving patients treatments that may actually benefit them clinically. Serial blood draws do not fall into that category. And so I have not enrolled additional patients to our study since early March. And equally, if not more importantly, remember that we're collecting blood draws throughout a patient's clinical experience, and we've not drawn any of those bloods on any patient since March. So like Smita just mentioned, we've been using this time, which was long overdue, to look at a lot of the data that we'd already collected and try to make sense of it and share it.
That is good to know that there is a silver lining in the research community, at least, of some things that we can be doing and learning. So Ellie, how about you?
Likewise, very much in the same situation as everyone else. We've been able to use this time to be very productive in the analysis front, be able to ask new questions of our data and perform new analyses, but at the same time, slow down in our clinical research studies. But we're hoping to pick up the pace on that soon to support the more mechanistic work that is tied into the grant and the related work.
Thank you. And Dr. Armenian, how about you?
Yeah, I echo everybody's statements about active research, but actually, you know, one of the issues in the survivorship world that we've been struggling with for quite some time now is how do we follow our survivors long term, not just in sort of the first year, but 5-10 years past that, and how do we understand what's happening to them physiologically in terms of their health and their well-being. And I would say that one of the silver linings of COVID is that there's been a renewed investment in telehealth and telemedicine as a way in which we can actually not only understand what their overall health is, but actually measure outcomes in patients. You know, we have Bluetooth-enabled devices that can tell us what someone's blood pressure is, heart rate is, what their blood sugar is. We can collect labs from individuals remotely. And I think as we start thinking about new paradigms in survivorship research in a growing number of survivors, we really have to be embracing telehealth and telemedicine as a way to do the research that we're doing. And in fact, I think COVID has really accelerated that. So I would think that for our survivors, there definitely is a silver lining and new methodologies and new ways of approaching problems. So I'm very optimistic about the future for our research.
Great. And a question that came in for you, Dr. Armenian, that really applies to almost every talk that was given is, you know, what happens if a patient has a bad biomarker? And you addressed that too. What happens if we know that there is a problem, but maybe don't yet have a solution? That's one of the toughest things, I think, for survivors and for people going through, you know, active treatment to deal with along with their providers. So, Cyril, I'll ask you to start on that one, and then maybe the others, if you'd like, would comment.
Yes, it's a very important question. It almost doesn't make sense to study an issue if there's nothing ultimately that you're going to be able to do about it, right? I mean, maybe down the line you will, but I think as clinicians, and I'm an oncologist, and I think one of the issues that is, you know, whenever we have a patient come to us, it's never sort of a linear approach in how we're going to treat them, right? We typically have to take into consideration a multiple of pieces of information, both in terms of the cancer and the patient themselves, and integrate those two pieces of information to give them the optimal therapy in front of them. When we're talking about these biologic signals or markers of who's going to get into trouble during the treatment or maybe years after the treatment, we then put ourselves in a position of saying, okay, what are the alternatives, and are those alternatives viable, and do they balance the potential benefit from the harm associated with it? Those balancing acts we do on a daily basis, and what these biomarkers help us do is actually make those decisions a bit easier, because then we can shepherd people in one direction or another. And I'll just give a quick example in the context of transplant, for example. We can modify the intensity of transplantation. We can do reduced intensity conditioning, myeloablative conditioning based on certain biologic and physiologic parameters. We can choose allogeneic transplant or autologous transplant in certain types of cancers where there are specific markers of who's going to get into trouble. And then, as the other speakers mentioned, in the post-treatment setting, there is emerging data of the role of not just monitoring for these biomarkers, but actually intervening early on. The cardiovascular disease world has embraced CHIP and clonal hematopoiesis as a target that they can actually use to prevent cardiovascular disease, because there is that association. So I would say that there's definitely multiple ways in which we can address this, and a lot of work that's being done, which is great. So,
Anne, would you like to add to that?
Yeah, no, I think that those are great points. And I didn't mean to be nihilistic about it in terms of there's lots of potential opportunities in the future, but right now everything is kind of either common sense and people should do it anyway, like diet and exercise, although maybe if you know you're a little higher risk than the average, you might be willing, and any other intervention is really at this point still in the research zone, except maybe changing what you're going to do from a transplant standpoint. So that's interesting. I learned that today, or from a treatment standpoint, although I think in many diseases that's not quite ready for prime time because there aren't always choices. I hope we get there.
Anyone else? I want to be mindful of your time also.
Well, we have been building upon our discovery with reduced connectivity in brain networks, and have actually been able to turn that into an intervention that is now funded by the National Cancer Institute. We're out these networks, and we're using transcranial direct current stimulation, small electrical stimulation to stimulate these networks and train cognitive skills during the stimulation as a way to help build up recovery of this process. That's from the recovery process. Ideally, the biomarkers that we're studying with the funding from the V Foundation would help us identify preventative methods that would help prevent the child from getting to that point where they need the intervention to recover.
That would be awesome. Others? Well, I would just like to once again thank everyone who has been a presenter today and for your hard and ongoing work. We're so proud to have you be recipients of V Foundation awards and grants, and look forward to working with you through the future. In a couple of weeks, you will be getting, or even sooner, you will be getting a survey about the symposium, and we hope that you will fill it out for us. And also let you know that the ESPYs, the great awards in the sports world from ESPN, will be airing on June 21st at 9 p.m. Eastern Time. And at the end of this, we'll be playing a wonderful PSA that will be airing. And to all of the participants who have been with us, and I noticed pretty much everybody stayed on, which shows me that this is real important work, and your presentations have all been so good and helpful to us. One more PSA, and then I'll wish you all well, and more to come.
Every victory over cancer is worth celebrating. From the small triumphs,
I will not let cancer define me,
to the big conquests. We celebrate every life saved by donating to save another.
It may not save my life. It may save someone you love.
Because of all the donations, mine is one of the lives that's been saved.
Life is worth celebrating. That's why we'll never give up.